All right, this last example from 5.8, this is something that should have been covered in Calc 1, how to take the derivative of an exponential other than e to the x. So let's just do a quick recap from Calc 1. So a little review here. If you take the derivative of an exponential equation, or an exponential function, I should say, let's say b to the x, where b is some number. Specifically, we're going to have b be positive, and b is not going to be equal to 1, because that would be a very boring exponential function. So some positive number other than 1. The derivative of this is, so it behaves very similarly to how you would differentiate e to the x. It is itself, but we'd multiply by the natural log of b. So precisely when b is equal to e, this formula becomes e to the x natural log of e, but natural log of e is equal to 1, so we just get e to the x. Okay. Another thing here that is worth mentioning, if we take the derivative of the, let's say, the logarithm base b, same restrictions as before, positive but not equal to 1, some base. So in this case, it would, again, be much like how you would differentiate a natural log, a logarithm of base e. In this case, it's 1 over x, but then we would also have the, I believe the logarithm, the natural log of b is in the bottom. And in fact, I can't quite remember if that is the correct derivative, because the natural log, the logarithm base b rarely shows up. A lot of times we have a way of working with natural logs. So let's just go ahead and prove this for a second, because I cannot remember. Let's do a little proof here. It's good to see it anyway. So let's let y equal the logarithm base b of x. Then if I base everything by b, so b to the y equals b to the log base b of x, well, b and log base b, they are inverse functions, so the right-hand side just becomes x, so then we have x equals b to the y. Now that it's written like this, we can differentiate each side. So this would become b to the y natural log of b equals 1. So notice that b to the y is just x. So this b to the y right here, I can replace this for an x. So x natural log of b equals 1. Okay. Oop, you know what I forgot? I forgot my implicit differentiation. Should have a dy dx here. My apologies. There we go. See, it's always good to do a little review of Calc 1. There we go. So then I will solve for dy dx, the derivative, which is what we're looking for. This is 1 over x natural log of b. That's the derivative of y, and y is this expression. So the derivative of this expression is this expression. So this is correct. Woo! Couldn't remember. Okay. So now we've got that taken care of. I had a quick little nice review of Calc 1 ideas, implicit differentiation, and these sort of less commonly known exponential and logarithm differentiation rules for other bases than e. Okay. So, yeah. So here, this example 3, let's go ahead and go through this one. Well, this would be, again, the inside function is linear, so I know I can treat the inside function, I can just leave the inside function alone and find the antiderivative, but we would have to pay the price of 1/2, the derivative of the inside function. Since it's linear, we can do the shortcut. So it's going to be 1/2, and this should be, well, 4 to the 2x natural log of 4 plus c. So is that correct? Well, that's the derivative rule, so we really should be dividing by this. So let's move that down a little bit. There we go. And let's do a little check here, because again, we can always check our work. So I'm going to quickly rewrite this to make it look a little bit nicer. I'm going to write this as 1 over 2 times the natural log of 4 times 4 to the 2x plus c. So if we do a check, we'll differentiate this expression. Of course, the derivative of a constant, an additive constant, c is 0, so that goes away. This is a multiplicative constant, so it just stays where it is, and we only have to worry about differentiating the 4 to the 2x. So this would become, leave that constant alone, multiply by the derivative of 4 to the 2x, which is 4 to the 2x times natural log of 4, times 2. So this right here is the derivative of the outside function. This, too, is, from the chain rule, the derivative of the inside function. So altogether, the 2's cancel, the natural log of 4's cancel, and we are left with 4 to the 2x, which is correct. So that checks out. So this is our final answer.